Okay, it's very early today. After what we did with the interim, I noticed that a lot of us cannot do the number system, like categorizing different numbers. So this video is by request from some of you that you really want to know it. So I'm gonna do it. And so I actually borrowed this little image online. I think it's actually from one of the algebra book. I think I've seen it before. And we are going to tackle this problem. I do think it's a problem, as in most people don't remember this or don't know this. Alright, so we are going to start. One thing I will adjust on this is I'll actually call it the real number system. Everything we deal with in math, all the numbers, fraction, decimal, negative numbers, square root of something, pi, all those are just real numbers. So it doesn't matter what they ask you. If they want you to categorize a number, it's at least a real number. So that's one thing I'll add to this chart. Everything in this box is what we call the real number system. And the most difficulties for students is actually the rational versus the irrational numbers. Alright, so I'm going to talk about that a little bit later on, and I want to tackle the three easier bit first, like the natural numbers, whole numbers, and integers. These three are much easier to understand, and sometimes it's confusing. That three number system, this only, the difference are not huge enough, and so people will not carry around this kind of knowledge in life. But it's one of those questions that in an exam they like to ask, like, is that something rational, is that irrational, can you categorize numbers? So we have to somehow deal with this situation. So as I said, we're going to talk about the three things that are relatively straightforward. So let's say if we have the number line, let's just draw the number line. In fact, this is the second time I'm doing this video, because the first time I messed up quite a few things. So let's say I'm going to just draw the number line over here. It's going to be 0 in the middle, is 1 and 2 and -3. Oops, that's totally not -3. That's totally not negative. Oh my god. -2 and so on. Okay, so that's the number system. What should I do with this? Yeah, we'll just keep it as that. That's our number line. So everything in math happens on the number line. And integers are the nicest group that we love to work with. Like in class, I'll say, give me an integer, and you'll say, well, 5. So integer is very easy to work with. Integer covers all these numbers. Like when we count each dot, like when we're looking at a diagram, we want to have a nice number, we are looking for the integers. So integers can be negative 1,000 over here, could be negative 515, could be 0, it could be 700, and so on. You can see the picture. They're just nice number on each of those dots. Not too much to say about it. It covers the negative side. Whole number on the other hand, we may like it even more. Why is that? Whole number starts with 0. That's the first element in this set. Okay, in this set we start with 0 and it goes on for the positive value. So that's 515 again. Okay, it's all the nice number with positive numbers, including 0. So that's the whole number system. We do not have the negative in there. We will have 0. It goes on forever. Not much to say about it. Natural number. Let me put this, it starts over here. That's where it starts. I'm still doing this on my laptop, and apparently this mouse is pretty bad at waiting. So it starts at 0. Natural number is even better, it starts here. So 2, 3, and so on. We love 515 today. Okay, so the three basic system, the whole number and natural numbers are very confusing. It starts with 0 for the whole number. For natural number, it starts with 1. And it depends on who you talk to. Some people actually will have the whole number and natural number combined as one simple set. That means they will include 0 in the natural number as well. And we are not going to dive into the argument. So as far as I'm concerned, we should be able to categorize these three, while whole number will have 0, natural number will not. So it depends on the starting point. Each of these sets is a little bit different. Alright, and then you may have this question and say, like, how about those decimal and fraction? Will that decimal and fraction show up in this group? Decimal and fraction? It's only reasonable to ask. Decimal or fraction? Where are they? These two types of number, they are not in the basic system, as in the integer, the whole number, and natural number, not inside here, not here. Okay, so decimal and fraction, they are not in here, and that's why we have what we call the rational numbers and irrational numbers to cover that. Okay, and so if we go back, now we know this is like 5 is in here, 0 is going to be in here, negative 10 is going to be here. So if they ask you to categorize like a number, you have a better way to go about doing it. And on top of that, everything is going to be real. And then we have the decimal and fraction will be somehow in this rational number system or irrational number system. So that's where we are heading. Okay. So when we talk about rational and irrational number, it's always nice to have a definition, and I just basically type out the simplest form of the definition. So for a rational number, okay, is any number that can be expressed as a fraction. Irrational number is just the opposite of that. The definition, I think, is straightforward enough, but most of the time people, look at it and like, I don't know if I can convert that to fraction or not. So that's normally the problem that people run into. So let's just talk about a couple examples. I just want to make sure that we are following what we are trying to do. So for example, like number 2, okay, number 2 you can convert it into fraction without any problem because it's going to be 2 over 1. That is a fraction, so it's a rational number. Alternatively, we can do something a little bit more outrageous. We can convert 2 into 8 divided by 4, so that's a rational number, right? It's a rational number. And then we run into problems, let's say, like I have 0.3. Is that a rational or is not a rational? 0.3 is just 3 divided by 10. Okay? So yes, 0.3 is going to be a rational number. It's going to be a decimal number. It's going to be a rational number. We can actually do something a little bit more. Negative 0.4, is that a rational number? Yes, this time it's a negative 4 divided by 10. So all of these will be rational numbers. If you can somehow find a way to convert a number into a fraction, they would be considered as rational. And then the next part that I do want to talk about, because not until we get this repeated decimal and terminating decimal out of the way, we can really dive into the biggest question of all. When will something not being able to convert into a fraction? So it's all based on this understanding of repeating and terminating decimal. So these two terms has been tossing around, I think in Algebra 1, that's when people do it. Repeating decimal, basically, let's say I have 0.3, but this time the 3 actually goes on forever. Okay, so the decimal is going to go on forever. And if you remember, we will write this like 0.3 with a dash on top. This little dash basically tells us that the decimal is going to repeat, and this is going to go on forever. Okay, the 3 is going to go on forever. In this scenario, we are actually saying that this is a repeating decimal. Oh my god. So this is repeating. This is repeating. Another example would be like I have 246, and then we're going to do 246 again. And the pattern is every 246, after the 246, we're going to have the same pattern again. So in this scenario, it's going to be 246, and that dash is going to be a little bit longer. We are repeating this 3. So again, this is going to be another repeating decimal. There's another repeating decimal. Then we will have terminating decimal. Terminating decimal, as the name implies, is going to stop somewhere. Alright, that is going to stop somewhere. So 0.375 is going to stop. It's not going to go on forever, so this is a terminating decimal. While there are some numbers out there, it will just not stop, and it's not going to repeat. So the most famous number is pi itself. Okay, pi, this number actually goes on forever. Okay, I'm not gonna write all of this. If you feel like to, you can just do a Google search on it. Pi actually goes on forever and it's not repeating. Alright, so when we are looking at decimal system, we have to be careful about repeating, not repeating, or it goes on forever, like for real, goes on forever without repeating is really going on forever. And the reason why I'm talking about this is because understanding the repeating and terminating decimal is the key to answer if something is rational or irrational or not. Alright, so pay really close attention to this. If you're given a decimal number, let's type this out because I can't type. If you're giving a number that's like a decimal form, you want to first check if that number is repeating or not. If it's terminal, if it's going to terminate somehow, that's going to be a rational number. Okay, if it's terminate, it's going to be a rational number. There will always be a way to convert that into a fraction. So like 0.3 is a terminating decimal, you divide by 10 is going to be a fraction. Then you went into like, is it repeating? Cannot write. This is just bad. So I'm just going to say it out. Is it a repeating decimal? If it's going to be repeating, then it's also a rational number. Alright, given a decimal, there are only 3 ways to go. Is terminating, repeating, or it goes on forever without repeating. Then you have yourself the irrational number. So this key to that is the way when they ask you this question, they'll really give you a decimal and they may say, is it a rational or irrational? The basic idea is you look at whether it's terminating, repeating. If it is, rational. If it is not, that goes on forever, non-repeating, irrational numbers. Okay, so hopefully that will help. I think I've done one of these questions with one of you guys. I can't remember which group. There's also another important aspect. So let's say if I have something that's repeating, and the question actually asks you to convert that into fraction. And I think it was one of the questions in the interim, and I noticed that that was the worst question of like 3 classes. So people actually do not know how to do it. So if they give you a number and say, I want you to convert this, so what I would do, I'll use some simple algebra to do it. What I would do in the beginning is I'll let x is equal to this. So let x is equal to this first. Okay, so x is going to be just a variable. This is the repeating decimal. It goes on forever with 7. I'm going to say this is going to be my first equation. So if you remember how to solve linear system, it's not too bad. So what I want to do is I will want to at least move this decimal one time. It doesn't have to be one time, it can be 2 times, it's up to you. When I say moving a decimal one time, what I mean by that is multiply by 10. Everything is going to multiply by 10. So if I do that, the first equation, everything is going to multiply by 10, I will get myself a second equation, which is 10x is equal to 7.777. Just moving the decimal is not going to change the structure of this number. The structure of this number is still going to go on forever, and the repeating decimal is going to be 7. So this is my second equation. Okay. Now, have a system of equation, then I can do a lot of lovely things to it, such as I can have equation 2 subtract equation 1. That's what I would do. So 10 minus x, you get yourself a lovely 9x. This bit 7.777 minus 0.777, you can see that all this decimal will cancel out. You get yourself a lovely 7, and therefore x is going to be equal to 7 over 9. And that actually proves to you why repeating decimal is actually a rational number, because I actually have a process to get it to a fraction. Alright, so this is it. I know this video is a little bit long because we do have to cover a lot of things. And if you're in my geometry, you will get this video through a message, and I'll tell you there's going to be an assignment assigned to this on Schoology for you guys. And so wait on it. Possibly sometimes next week is gonna be due. So it's about categorizing number. So you look at the number and try to categorize that. Okay. So bye for now.